SRHacks 2023. On behalf of the SRHacks team and the Science Rendezvous team at UofT, we want to welcome you all to our hackathon competition for this year. My name is Eduardo Garcia, and I'll be the host for this presentation. And I will be touching on a couple of details regarding kind of what the competition is about, what kind of resources are available to you, and also we'll be hearing a little bit from the Dean of Engineering at UofT, Dr. Christopher Yip. So stay tuned for that. So what is SRHacks? SRHacks is a programming and engineering competition that's tailored for middle school students, and it serves as a way or as an entry for students that have no idea or have no experience in engineering and coding to begin developing these skills. It is a 2-week-long event competition and is organized in the form of a hackathon. And a hackathon is an event where engineers, programmers, graphic designers all come together to work intensively on creating a specific product to answer or address a specific question. And just like many of you will be doing over the length of these 2 weeks, you will be creating a project or a tool to answer the challenges and the theme of this year's 2023 competition. So to talk more about the competition, typically hackathons occur between 2 to 3 days, but because this is supposed to be also a learning opportunity for people that have no experience in coding or engineering, we are extending the length to 2 weeks to give everyone enough time to develop the fundamentals before begin putting together their projects. So again, the competition could either be done by yourself or in groups. And during that 2-week period, we're also scheduling what we call learning events. And these learning events are things like workshops, help sessions, speaker series that are meant to kind of not only help you guide the development of your project, but also maybe incentivize you or motivate you to continue to develop these skills outside of the competition as well. And then at the very end of those 2 weeks, we'll be choosing the top 5 finalists who will then be invited to join our finalist event, the SRHackoff. And more information, we'll delve into more information as we proceed through this presentation. So the learning events, let's talk more about them. Starting with workshops, these are tailor-made to serve as a reference, but also as a tutorial, or you can think of them as classes where our host will essentially teach you the very basics that you need in terms of either coding basics or engineering basics to give you an idea on what you need to know and what you need to do to start putting together your project. This is a great resource for anyone that's an experienced engineer or programmer. And especially if you're just new to this, I highly recommend that you register for these events. If you are interested, after this presentation at 2:10 p.m. Eastern Time, our first workshop will be hosted by Andrew McDonald, who will be going over, but in a step-by-step format, showing you how to put together your project. So this will be an excellent resource for you guys who are just getting started. And again, if by any chance you don't have time to attend, all of these events, including this opening ceremony, will be recorded and will be made available to you later today. In addition to the workshop, we also have what we call a speaker series, which are kind of seminar talks where we invite professionals to come and give us talks about their work experience. In particular, how they use these programming and engineering skills that you're going to be developing during the competition to give you an idea on how these skills apply in the real world. And the purpose of these talks is to hopefully give you, I guess, a better look forward in the future to kind of help guide your own professional goals as well. And finally, the SRHackoff competition is a finalist competition. And this is where the top 5 groups will compete to see who will be the top innovator for the 2023 competition. But this event is open to the public. That means all of you are invited to attend. And even though this is an in-person event, all of you, even if you're a competitor, are allowed to take part in it virtually. And more details on that will be made available as we draw closer to the date. So a couple of rules and about and I guess eligibility for the competition is that, again, this competition is offered just for middle school students. So that means any student from grade 6 to 8. And as to how you participate, you can either go at this alone by yourself, and we have had finalists that have created projects and been successful just on their own. But if you have friends or someone you want someone to collaborate with, we do allow teams up to 4 students maximum. And the last, and I guess the most important question is, do I need to know anything about engineering or coding before entering this competition? And the answer to that is no. This competition was created to serve as a stepping stone for those that have no experience in coding or engineering, to help you begin develop those skills. So if you're in an attendance and you have no idea how to code, or I'm not sure what engineering even means, you're in the right place. So don't worry about it. Now, in terms of how we grade the projects, at the end of the 2-week competition, you will be submitting to us your final project, which will be in the form of a file that you submit to us directly. We then pass this over to our judges, who will then give you a grade and also some comments that will also distribute to you all. And after the judging period is done, we will decide who are the top 5 finalists that will move on to the SRHacks. And in this finalist event, the top 5 teams will then give a 7 to 10 minute presentation and answer questions in front of a team of panelists, who will then pick who would be the top 3 teams for this year. So it wouldn't be a hackathon competition if we didn't give you guys a challenge or a theme to work towards. So I'm happy to announce that the 2023 theme is healthy living, good health, and well-being. So this is to ensure healthy lives and to promote the well-being for all at all ages. And this was actually adopted from one of the UN 17 global goals. And what it entails is that the aim of this goal is to make healthcare accessible to everyone. And this can be done in a way that we provide either a tool or a product that helps the user either live a healthier life, or the tool helps make the world a safer place to live in. And the challenge that we give to you all this year is that we challenge you to create a tool or a product that addresses these goals to help the user of your tool or product live a healthier life or improve the well-being in some way. So this simple example could be something like a small tool that you carry around with you that sends you a message reminding you to maybe get up every once in a while to walk around while you're working, to make sure that you're getting the little bit of exercise every once in a while. So the great thing about this goal is that it's very broad, and it encompasses a lot of aspects that ultimately can affect our well-being and our health. So it gives you guys a lot of room to be really creative. And I, for one, can't wait to see what things you guys come up with. So speaking of this, I think a lot of you might have some questions as to how do I even, like, what does the project need to be in order to meet these criteria? And to answer those questions, every project is composed of 3 components. The first component is a programming component, which is going to be a file that's called a .hacks file that contains the code that you put together to make your software. And then that will be followed by the engineering component, which is actually just a video file of you showcasing the physical attachment that complements the software that you made. And then the third component is it's a written description, which is meant for you to gives you the opportunity to tell us about your project, what kind of problem you're solving, and how that meets the themes of this competition. So this was kind of like a very broad description of what's included in the project. So let's take a look at each of these points a little bit more closely. So starting with the programming component, this year we'll be working with what's called a microbit, which is a pocket computer that's actually made as a tool to, again, help students get into programming and learn how software interacts with hardware. Now, in this description, it's kind of showing all the little functionalities that this little device can do. And I don't want you to feel overwhelmed by it. You don't have to create a program that uses all of these things. This is just a way to show you that you can do a lot of cool things with this little device, and gives you a lot of room to, again, be really creative with what you make. But the big thing that you're going to be mainly working with is kind of this little 25 LED display, where you actually will be able to show things like messages or diagrams. And so it gives you an idea to kind of, or more room for you to communicate things to your user. And the way that you code or you make programs or apps for this little computer is actually very simple. It all happens in what's called the MakeCode development platform. And this is a picture of how it would look like. And the way that you access it is that you just go on your computer and you can access this from any browser. So you can go into Google Chrome, type in Microsoft MakeCode, and it will take you directly to this development platform. And once you've accessed it, you can then set the coding language to block language, which is why I suggest if you're just a beginner. And then you can get started to play around with it and see what kind of blocks work and in which way. And one of the things that I do want to stress is that for this part of the competition, you don't need a physical microbit. Any code that you make can be tested all in the same platform via the virtual microbit that you see there on the left. And you can play with all the functionalities that I showed you in the previous slide, where you have the buttons. You can play around with those, with the microphone, with the tilt functionality. Anything that you want to include in your code, you can test all virtually here. And once you're done with your program, you will then export it into the .hex file that I mentioned, and you will then be able to upload that directly to us, and you will essentially have completed the first item of your project. Now, the second item of your project is the engineering component. And this is what we meant by a physical attachment that complements your program. Let's say that you have a microbit and you decide to make a clock, just a simple clock program in the macro as a microbit app. One idea of a complementary attachment to it would be maybe a strap that attaches the microbit to your wrist so you can carry around with you, so you can tell the time wherever you go. So we want to provide this opportunity for you to get really creative and build something really special. And the way that you will showcase this to us once you're done making your physical creation will be by taking a video of it and showing us how it would interact with your program. Now, as we said before, you don't need a physical microbit. What you would do in the video is that you would have a little placeholder. It could even be just a little card. And you would essentially just show us in the video where you would put the microbit and how does the microbit interact with your physical attachment, hypothetically. And you would then submit this video format along with your .hex file as part of your project. Now, the next and the last part is what we call the promotional component, which is your written description. And it should be just a really small description, 5 words maximum, where you tell us the background. So that means what issue are you solving, the purpose of your device or your invention, and how it addresses that issue. And the conclusion is, how does that then fit into the theme or answers the challenge that we provide to you in 2023 of healthy living and well-being. And then after you're done, you will save that document and you will submit that as the very last component of your project submission. So at this point, you essentially would have been completed your project. And I do want to bring your attention to a couple of deadlines to keep in mind as you're going throughout these 2 weeks. So the first one is that if, for example, if you're all here today, you probably are registered already. But in case you have friends or anybody that hasn't registered yet, the hard deadline to register is April 15th, which is the next Saturday. And in terms of project submission deadlines, you have until April 22nd at 8 p.m. to submit your project. So that's a whole 2 weeks for you to listening on the workshops and put together your project with your team. In terms of when we announce the finalists, we have this schedule for May 1st. We should have an idea of who the top 5 finalists are. And then the finalist competition is going to be hosted on May 13th from 1 to 4 p.m. at the UofT campus. And I do want to say that you don't have to be there physically. You can attend virtually. And more information about that will be made available to you all once we draw closer to that date. Now, I do want to bring your attention to a couple of resources that you have at hand to help you through this journey. The first one is the learning workshops, which we just described earlier in this presentation. And then the second one is the mentor help sessions, which are sessions that we host, where you will be able, with your team or on your own, to meet with a mentor, this being a university student that has experience with coding and engineering, to ask them questions specifically about your project. So these are great opportunities if you have a pressing issue, maybe there's something you can't figure out. These are great opportunities for you to come in and get direct help with those problems. And the last one is the Discord server, which I mentioned to everyone already. And this acts as our community hub where you'll be able to join, talk to other participants, and this will also be your direct line to ask questions to us directly if you need to. Is also a good place to find announcements, and also we have a schedule there of all the upcoming events and also registrations for them as well. So I do want to touch on the drop-in sessions a little bit more. So again, these are mentors, volunteer mentors that we have available. They have agreed to give an hour of their time for you and your team to come together and work on any issues that you might have specific to your project. And these are students that have experience in programming and engineering, so they'll be able to help you to whatever issues that you have. And in terms of how the sessions will run, this will be up to them. It will either be on Zoom or in the very Discord server, and you don't need to register for these. All you need to do is just keep an eye out for emails around the time that these sessions are scheduled for, and they should have information on how you should join and what to proceed and how the session is going to run. In terms of schedules, these are the 4 dates that we have available where these drop-in sessions should be expected. They're typically about an hour long, and we have 4 of them set out during the 2-week period of the competition. We also have these schedules available on our website and also on Discord as well. Now, in terms of important links, we have a link to the information package, which some of you should already received through an email. But if you haven't, this is a good opportunity to then take a look at it. It essentially has all the information that I just went over during this presentation, as well as other useful tidbits. And we also have a Discord link for you to access our server. If you haven't used Discord previously, I do recommend that before getting started, that you create an account with a parent guardian next to you, and then you can join our server thereafter. If you don't have a chance to scan the link here, the link is also available in our website. And speaking of our website, there's a link here for our website as well, where we also have the registration links for other events also. Now that we draw close to the end of the opening ceremonies, I do want to bring in the Dean of Engineering at UofT, Dr. Yep, to give us a couple of inspiring words before we get started in this 2-week-long journey. So without further ado, Dr. Yep, the floor is yours.
Great, thanks, Eduardo, and really great to be here this on what is a nice sunny afternoon here in Toronto, and welcoming folks from around, as Eduardo said, around Canada actually to be part of this SRHacks, a terrific opportunity for you to investigate and solve and address really challenging problems. And as Eduardo mentioned, I'm the Dean of Engineering here at the University of Toronto, and we have, I think we've got nearly 6,000 undergraduates in our engineering program, all studying science, technology, engineering, math. But more importantly, so many are actually pursuing efforts in the creative arts as well. In fact, I don't know how many of you knew that you could actually do a music performance minor in engineering at UofT, which is pretty amazing. And so many of our students are actually at that interface between the arts as well as the engineering sciences. But what's really cool about this is that engineering, and I grabbed this because I just got back from a giant trip to Taiwan and Singapore. Engineering is really a passport to a whole host of different realms, a whole host of opportunities as you're going through. I didn't know what engineering was when I came in at your age. I was always interested in building and being creative and solving problems. And that's what everybody does all the time. So in many ways, what you're about to embark on over the next couple of weeks in this little challenge that you've been given around healthy living and healthy aging is really just a challenge. It's a problem. You're going to go out there and identify something, and you're going to solve it. And you're going to come up with a cool strategies to do it, and using unique technologies, which I think, amazingly enough, have just evolved so quickly. I was thinking, Eduardo, as you popped up, I didn't realize you guys were going to use the microbits, because I have one. I have a physical one at home because I give it to my kids to play with. These are things that I didn't have back in the day when I was coming to and trying to ideate and come with solutions. And it's amazing to think about where technology has got us these days, and the impact that you, even though you're in grade 6 to grade 8, are going to have in the future. And there's all sorts of really cool things to think about. and I kind of dug into I have a drawer full of stuff. And I kind of went like most of you probably have one of these, right? You have your smartphone and you can do all sorts of stuff on it, right? But then if you think back maybe 10, 15 years ago, you might have had a phone, you can't hard to see this, looks like this, which definitely didn't have touch capabilities, had a physical keypad that you touched and that did stuff, but isn't anywhere close to what these phones can do today. As I was saying, I was just over in Asia, and it was amazing that I can be sending email, I can be sending video, I can be chatting with my colleagues 12 hours at a phase, but over a device like this, when 15 or 20 years ago, that wasn't possible. The only thing that remains constant is that it has to fit my hand, right? That's the user interface to think about. And you think about the power you now have in these tools, the ability to do all these things, that's really where the magic lies. That's really where it's sort of people being creative and saying, you know, I've got something that's like a phone and I can make a phone call on it. But what if? Could I do this? What else could I do if I had all this information in my hand? I can, yes, and you've all done this. You can, your parents have done this. You can amazingly call a cab, right? You can check the weather. You could, as I did, send a video call to a friend, you know, halfway around the world and chat in real time, right? The thought of even sending emails 10, 15 years ago was part of a amazing, right? You used to send text messages and come up with really short codes because you couldn't write giant messages to people. Sending pictures, that sort of stuff. It's all because you had this unique interface between someone who can design a physical device and those who come up with the creative ways in which you can use it. And I think that's really where what we're looking at here is asking you to think about what are some of the challenges that people face in everyday life. Is it when you're in grade 6 or grade 8? Is this a challenge that your parents may have? Is it a challenge that a friend may have? Is it a challenge that your grandparents may have? And I think this is something that's really intriguing as you sort of look around and realize, wow, if I could just do this, or I could build a device to do this, this could really help a whole host of people, not just in our neighborhood, not just in your family, but around the world. And I think that's really what engineering is about, is how do you solve these global challenges and using technologies or approaches that really let people come up with creative solutions, ways that work for people in different areas of the world, in ways that may be inexpensive, ways that are accessible to everybody. Not everybody can afford a smartphone, but how could you build technologies which still give them the same access, but in a different way? I think the other part about this, and the other thing that you're going to see is, as Eduardo mentioned, you can work in a team of one, you can work in a team of four, but that's really what engineering is about. Engineering is all about working together as a team, bringing people together who have different perspectives on the challenge, different insights. Some of you may be great coders. Some of you may be very creative and come up with great ideas about interfaces and saying, well, this would be great if we could put a button here or make this a different color because people see colors in different ways. And someone say, well, I can code that for you, but I'm not sure how to make a physical device. And someone else can say, well, I'm really good at building physical structures and different wearable things. For instance, you showed a great example of the microbit attached to like a Velcro strap. It's like, well, how do I build that? Who can build that for me? And where's my team? And how do I bring these different perspectives to bear on the challenges? And this is something that engineering is all about. It's not just about those who can write code really fast or solve a calculus problem really well. It's about that entire community that you bring together. Those who have creative perspectives, those who have artistic perspectives, those who have lived experience, someone who's worked with different devices. It's all about looping them together into thinking about these challenges. So we really focus on doing that, but then thinking about the future, right? How are these things going to evolve? You probably all heard that we just announced the first astronaut, the first Canadian astronaut that's going to go around the moon on Monday, right? And this was an amazing accomplishment. And you think about when was the last time we went to the moon or went around the moon? You know, that was decades ago, right? And now we're coming back and we're starting to think about like, what can we do out there? What are the creative things that we can do and how can Canada participate in that? And you're going to be part of that journey. Because you are actually intriguing enough. I want you guys to make a mental note so you can email me when you get to university and realize, actually, you mentioned this to me when I was in grade 6. Now, 20 to 30 years later, I am actually going to be the next person to go to the moon. I would love that if that was actually something that came out of this particular talk. But this is sort of the things that we're thinking about the future. Where can engineering take us? Where can we start to bring these technologies together to really look at massive challenges going forward? So you do represent the next generation of makers, innovators, creators, those who are going to come up with the really cool ideas, those who have the curiosity and the passion to drive projects forward. I want you to think big. I want you to think of really cool challenges to look at, areas which others have not actually thought about. You may have had this idea percolating in your head for a while. Now's a chance to go for it. Come up with that. You've only got 2 weeks to do it. Not a lot of time, but you're going to be able to pull it off. I have full confidence. And again, as I said, engineering really is, it's about a foundation. It's going to build a passport so you can go off and venture into different areas. And we'll find that engineers are in all sorts of disciplines. I'm always amazed when I talk to our 50, 60,000 alumni of UofT engineering, where they actually are. Some of them are actually engineers. They actually work as engineers. Others are working as lawyers. Others are artists. Others are helping develop the next generation of the banking system. Some of them are working in sustainability. They're all everywhere. So engineers are making massive contributions to the success of the country, success of the world. It's all about making people's lives better, right? And coming up with solutions to really challenging problems. So we need you. We need you to be part of this journey. Part of this journey. I want you to all get your passport, as it were, moving forward. And with that, I'm going to hopefully giving you a little bit of inspiration about what you're going to be doing the next couple of weeks. And I'm going to hand it back to Eduardo. I'm actually I'm around, happy to take any questions if you might have any for me. So with that, I'm going to hand it back to Eduardo and the team. I'm really looking forward to what you guys are going to be able to come up with next couple of weeks, and have a ton of fun.
Thank you so much, Darshki. I'm actually really glad that you touched on that mindset of what if, and that to actually really get excited of what the possibilities are of you creating something really special that could actually benefit others around you. With that, in terms of questions, I don't know if my team is anyone in the chat that have any questions? I guess there's a couple of ones here. I guess one of the general ones I think people would love to ask you is that what makes a successful engineer in your opinion, for someone that's just starting out? Yeah.
I think what makes a successful engineer is really someone that is able to take a concept, right? Take a question and really just sort of move it through the process of thinking about a solution, thinking about alternatives, and testing it, right? Things don't work the first time you try it, right? I was just thinking about, you look at SpaceX, you fire a bunch of rockets up, a lot of them don't come back down, they blow up. It's about testing, it's about trying those things out and having that perseverance and the ability to kind of think of, well, that didn't work, let me think of another solution, and not to stop, right? It's about persevering, working through those challenges, because there's solutions out there, and working together. Those to me is a successful engineer, someone who can think of the problems, work through some of the challenges along the way. Stuff doesn't work the first time you come through. Being resourceful, being resilient, being creative, actually, the last one, having fun. The key to all of this is make sure you're having fun.
Of course, yeah, and I think that's kind of some of the little bit of the goal of SRHacks, is to show how these programming engineering could be really fun. But as a successful engineer yourself, Dr. Yip, can you give us a little bit of a glimpse on kind of your journey going from point A to Dean of Engineering at UofT?
Point A to point B was not a straight line.
Yeah.
It was definitely not a straight line, I'll tell you that much. It's a lot of weaving all over the place. For me, it's I'm always learning. This is an ongoing journey. I don't even know if I'm at point B yet. I think I'm on my way to point B, as it were. I think I've done all sorts of different things in my life. I never thought I would be an engineer. I never thought I'd be dean. Let me just put that out there. The dean, there's an analogy, it's kind of principal of a school, the CEO of a corporation. I never thought I'd be in this role. I always thought I'd be, at the best, I would just be sort of, working on problems and solving things. And I'm always curious. So I for many of my colleagues and many of the students who I have coffee with one-on-ones all the time, they know I get excited about challenges. I get excited about all sorts of stuff. And that makes my journey very nonlinear. It's all over the place. But it's been a hugely variable and exciting path to becoming the dean. Starting as a student, becoming a faculty member, running my research group, teaching students. I still teach classes now. I still teach a graduate course. I still teach undergraduates. To now working with the rest of the university and colleagues around the world to try to solve big problems. And my role is to provide the resources to have that happen and to work with the students. So
I think
it's
that's
a ton
amazing.
of fun. And
yeah, I think the fact that you're dean and you still find time to also teach a couple of these classes is very, it's very impressive.
Well, it's honestly, it's a ton of fun. I love, teaching, giving lectures, even though there's students on this list who probably think faculty hate giving lectures. Giving lectures has got to be the most fun I honestly have in a day, because it's a chance to engage, a chance for me to learn. I don't know the answers to lots of stuff, and I love when students ask me questions in lecture about why is this important? What can I do with this? Can we learn about this instead? And for me, that's the best part of a day.
Yeah, and I think honestly, as a UofT student myself, I think I was very glad to have educators like yourself that would like to engage the students even beyond the academic side of things. So that's fantastic. I think the last question that we would like to ask you is that with our young participants here, do you have any advice for anyone here that has no programming or engineering experience that may have their sights on becoming an engineer one day? Any advice in terms of beginning that journey?
If they don't have programming experience, I think actually, you know what? It's an interesting question, because engineering is not all about programming. In fact, we don't even require programming to go into engineering. We teach it to you in engineering. So we have lots of students who've come in first year who have not written any code. And I think that's actually something that's intriguing to think about, because a lot of these tools, they're there, but programming isn't the only thing that makes engineering. That's actually, to be honest, that's one of the challenges I have with hackathons, is it's always about writing code. And it shouldn't be, right? It should be about other stuff as well. In fact, physical hacks, I think, are actually a lot more fun, but a lot harder to do virtually, because here's something to build. But I think, programming is it's language, right? That's really all it is. It's teaching something to do something by giving it a sentence for the device to read. So to learn programming is actually, it's not that difficult to do. It's really just learning. It's honestly learning a language. And as you showed in actually some of your early stuff with the microbit, it's graphical at some level. You just drag and drop things and it does stuff, right? So it's all about learning syntax. And many students I know know multiple languages. And your ability to know multiple languages as you talk to folks, right? So I don't know very much Mandarin, but I'm learning Mandarin. But I know French, and so you learn the syntax, and that's all coding is learning language and how to pass instructions back and forth. That's really being able to translate between different languages. So it's kind of hard to explain. Kind of have to just go out and try it.
I think the sentiment is the fact that there are students that enter university that enter the engineering program with no idea what they're doing, and then by the end of it, they become successful engineers. I think this was an important point to make, because I think it alleviates, I think, some of the worries of students who feel that they might not be adequate I feel that it's okay not to
Yeah,
know things, and that's the purpose of learning.
totally. 100%. Because we have a lot of students who we want to make engineering accessible to everybody. We have a lot of students that, they don't want to write code per se, but they do like math or they do like chemistry. Or we have a lot of students actually very interested at that. And your particular problem is right at that interface, which is human device interface, right? They call it human interface or a user interface or whatever, that kind of description. How do humans interact with technology? And that's a space which is super important right now, right? Because not everybody can type on a keyboard. Not everybody can use a touch screen, right? How do you build devices that work for everybody and that can detect things? Like I found something real. I didn't even know. Well, I know this. Didn't realize it was a problem. A lot of elderly can't use touch screens, and the reason is because their fingertips are often dry. So they can't make physical contact with the screen. So you have a lot of folks, they use a touchscreen and it doesn't respond. And that's because their fingertips are dry. And it's like, well, who would have thought of that as a problem, right? And that's a huge issue now. Anyone who's got any kind of visual impairment, right, or inability to kind of control their fingers, they've got a tremor, really hard to use a touchscreen, right? People designing touchscreens have to think about that kind of interface. I had a great conversation. This is way off topic. I had a great conversation with someone about cars these days. Now, okay, probably most of the folks on the call will never have to learn how to drive because you have autonomous vehicles. But right now, I think one of the biggest problems in cars are touchscreens because you have no tactile feedback, right? And you're always hunting to touch something. Your eyes are off where you're driving as you're trying to touch a touch screen and make sure you hit the right thing. It doesn't work with your gloves, a whole bunch of stuff. If you went back to knobs, physical devices, a lot easier to handle. People can do that without looking for stuff, right? But we moved to touch screens because they look cool. They're actually not the greatest way to interface with a vehicle, personally. Someone who drives a car that has either a touchscreen or a physical interface. But I'm old school. So I'm not sure that's going to work for some of our other folks here, but I think ask yourselves that question. Actually, the next time you see your parents driving the car and trying to navigate and using a touch screen in the car, and ask yourself, would it have been a lot easier if you actually had a knob to dial stuff?
Yeah, there's some homework for everyone there.
Yeah.
Okay. Thank you so much, Dr. Yip, for joining us for the third year in a row. We love having you here and the value that you add to this competition because of your words and the inspiration that you bring. So thank you once again for being a part of it again.
No problem. Have fun, everyone. Enjoy. Looking forward to seeing what you come up with in a couple of weeks.
All right. Thank you. All right, everyone. So now that we are reaching the end of the presentation, I want to just bring your attention just to a couple of housekeeping items. So again, don't forget that after this presentation at 2:10 p.m. EST, we're hosting our first workshop, and this one is going to be surrounding around how we use Microsoft MakeCode to make software for the microbit. And then in addition to that, a couple of tips on how to think about how to create a physical attachment and how to engineer one using household items. And this will be hosted by Andrew McDonald, who has over 10 years of experience bringing this type of information to students in the classrooms like yourself. The other thing I want to also is to thank everyone that's helped organize this event for everyone, beginning with the national organization team, the UofT team, and as well as our contributors and volunteers, and our sponsors and other funding sources as well. Now, at this point, I want to open the floor just to address a couple of questions before we close it off. Before I guess to you or Jenny, tell me any questions that have popped up. I have seen a couple while I've been here presenting, and I just want to address those. The first one is someone asked if they can use any other type of coding language. Ideally, in the actual interface, you are allowed to use Python as well, but we recommend to use block code instead, just because it makes it easier also for our judges to really understand where your code is coming from. One of the best ways to also, just as a note, is that when you put your code in, even as a block code, you have the option to right click and add a comment. And I highly suggest, well, it's actually part of the rules that you're supposed to do this, is to add comments to your code to let us know what is the purpose of that little line of code that you're writing. If you're fully inclined to write in Python, you can, but I highly recommend that you keep it in block code just to make things simple and to allow the judges to really be able to appreciate what you've written, just because it can get a little bit messy. Any other questions? Let's see. Yes, so a question from James. The workshop will be recorded, as well as the opening ceremony will also be recorded, and these will be made available. But the benefit of attending the workshop, if you can, is also that there might be a question period at the end where you can ask our host specific questions about what they've gone through. So it's a good learning opportunity for there as well. Do we have any other questions that have gone through the Q&A? Suyi and Jenny, anything that I'm missing? No? Okay. Here's a good question again. Download software? No. So MakeCode, the platform where you're going to be creating your block code, is all ran through any browser. So this is Chrome, Firefox, whatever you have. So there's no need to download any additional software. The only thing that you will be downloading is after you're done coding, you'll have to export your hex file that contains your code. That's the only thing you'll need to download, because that's part of your submission as well. So yeah, great question. Thank you. Again, I want to mention that we do answer questions throughout the day in our Discord. So if you haven't accessed that yet, I do suggest that you head over to our website, and then our Discord link is there. Just make sure that if you're new to Discord, to make your account with your parent or guardian. They're supervising you during that process. And yes, again, as Dr. Yip said, that one of the best things about these type of competitions is the collaboration aspect. Although you can completely go through this competition working on your own, you do have the opportunity to work with other people as part of your team. The only limitation is that every team can only have a maximum of 4 people. But aside from that, you can pair up with whoever you want, as long as they are in elementary school, so grade 6 to 8, and also that your teammates have registered. There's also no need for you to tell us who's registering your team at this time. You will be able to tell us specifically who's in your team when you submit your project at the end of the competition. So great question there. So someone asked about when you start working with your partners. You start working with your partners as soon as you have the group together. So if after this competition you call 3 of your other friends and you get together to plan out a project, you can start working on your project and putting together everything as of now all the way until the end of the competition. So there's no need to wait. Just make sure that all of your partners in your team are registered and that they are indeed in grade 6 or 8. Okay. So I have a question here about communications. One of the best tools that we have for communication is a Discord server. So if you have a partner and you know how to contact them specifically, next time you see them or you communicate with them, just let them know to maybe access the Discord server using the link in our website, and then you both can then talk on Discord or on our server directly as well. So that's a good resource to communicate with one another. Okay, anything? Okay. I'm not seeing any more questions. So again, if you do have any pressing questions that maybe you don't want to ask right now, just send them over on our Discord server, and I'm sure someone of our staff or anyone else will get to them and answer your questions there as well. Again, yeah, if you do decide to talk to your partners on our server, everyone will be able to see them. But Discord is a platform that encompasses other services. So you'll actually be able to message them directly outside of the server. So you'll be able to call them, chat to them privately in your own chat group as well. So don't worry about that. Yeah, so the Discord server is live and is open. So if you haven't already, I'm sure one of our staff could give the link to the website, where you'll be able to find the link to our Discord server and join there as well. So yeah, great questions. Okay, so we're gonna close it off now, and we're gonna give you guys the opportunity to then head on over to the website, get into the Discord server, and also register if you can to the workshop that's gonna happen right after this presentation. Again, if you're not able to meet with us there, then everything will be recorded and will be posted in our website and our Discord server as well. So thank you all so much for joining, and I'll see you soon.